You ever get that feeling when your phone does something weird, something you just can't explain? Well, that little flicker of confusion, it's actually a tiny window into a massive, invisible problem. We're diving into what's being called the complexity crisis, that moment when our own technology got so powerful, so tangled up, that no single human could possibly control it all. So that brings us right to the heart of it, doesn't it? What really happens when our own creations get too smart, too complex for us to manage?
Well, the simple and maybe kinda unnerving answer is it's already happened. Let's unpack what that actually means.
Okay, first up, the complexity crisis. This isn't some sci-fi future. We are living in it right now. Our digital world has quietly grown way beyond the limits of what a human being can directly manage.
I mean, just think about it for a second. Inside a single microchip, what they call a multiprocessor system on chip, you've got billions of possible pathways for data to travel. Billions! Then you zoom out and you have these massive global cloud networks that connect everything everywhere. The scale is just mind-boggling. It's gotten so huge that it's literally impossible for any one person or even a big team of people to keep track of every little detail.
So if this runaway complexity is the fire, how do you fight it? Well, it turns out the answer is to fight fire with a totally new kind of intelligence. We're fighting fire with AI. We're stepping into this whole new era of management. We're not just building tools anymore. We're building tools to manage the tools that have become too complex for us. And this isn't about replacing people. It's about giving us a way to actually stay in control of these massive, complicated systems we've built. And this is the new toolkit we're using. We're talking about really advanced stuff, like AI and something called fuzzy logic. Now, I know fuzzy logic sounds kind of funny, but it is brilliant. It's basically a way for computers to think a little more like we do, to handle things that aren't just black and white. You know, instead of a simple yes or no, it can understand maybe or sort of or just a little bit. And that lets these AI systems look at huge amounts of messy data, juggle a bunch of conflicting goals, and find the best possible solution when there is no single right answer. All right, to really see this in action, we've got to zoom way, way in. I'm talking down to the microscopic level of a single computer chip, because this is where the complexity crisis is happening every single nanosecond. So inside that chip, you have what's called a network on chip, or NOC for short. The best way to picture this is to imagine all the different parts of the chip, the main brain, the graphics processor, the memory, as different neighborhoods in a huge, bustling city. The NOC, that's the super complex highlight system connecting all of them, with data traffic zipping around constantly. Now here's the nightmare scenario for the people who design these things. Every little piece of data needs a route, but what's the best route? See, one path might be the absolute fastest, but it sucks up the most power and generates a ton of heat. Another path might be super energy efficient, but it's slow and it'll make your device feel laggy. Every single goal is at war with another one. And this table here, it really drives the point home. Just look at these numbers. The algorithm that's fastest, that's ADBR, with the lowest latency, it's not the one that uses the least power. And the one that sips the least amount of power, Catra, has double the latency. It's this constant, messy balancing act with no easy answer. You just can't have it all. So how on earth do you solve a problem that has no perfect solution? Well, this is where that fuzzy logic comes back in. Instead of trying to find that one perfect route that doesn't exist, a fuzzy logic system acts more like a wise advisor. It takes all those conflicting goals, speed, power, heat. It weighs how important each one is for what the chip is doing at that exact moment, and then it finds the optimal balance between them. It navigates all that gray area to find the best possible compromise, and it does it in real time. Okay, so that's the wild, microscopic world of a chip. But let's zoom back out. What does this new age of AI management actually mean for the people who, run these systems? How do we future-proof our own skills? The answer to that is a field called AIOps, which is short for AI for IT operations. And this is where we're using AI to run the day-to-day digital world. Its job is to automate all the boring stuff, predict when systems might fail before they actually do, and handle problems as they pop up. You can think of it like a tireless digital teammate that handles all the grunt work, a super-powered system administrator that never gets tired and never needs a coffee break. And this changes the game completely. In the past, IT management was all about being reactive. You'd wait for an alarm to go off, and then everybody would scramble to find the problem and put out the fire. But with AIOps, it's proactive. The AI is constantly analyzing data to spot potential failures ahead of time, letting teams fix issues before they blow up. And that frees up the human experts to stop just firefighting and start thinking about the bigger picture, about strategy. Which, of course, leads us to a pretty big question. If the AI is handling all the technical, routine stuff, what's left for the human experts to do? What's our role in this new world? Well, as it turns out, as automation takes over more of the technical, repetitive work, our uniquely human skills, our so-called soft skills, become more valuable than ever. Things like being able to explain a complex idea to someone who isn't a tech expert, or thinking critically about what the AI is telling you, or working with a team to solve a really tricky problem. These are the skills that can't be automated. This is where we shine. But there's a huge catch in this whole story. This incredible power that AI gives us, it's not just a tool for building and managing things, it's also a weapon.
Yeah, the very same AI technologies that are helping us defend our complex digital world can be, and absolutely are being, used by hackers and threat actors to attack it. And this dual-use problem is one of the single biggest challenges in cybersecurity today. It's really two sides of the same coin. For every amazing defensive benefit that AI gives us, like automatically spotting new threats or responding instantly to an attack, there's a dark side. Bad actors are using AI to create brand new malware from scratch, to generate scarily convincing deepfake videos for scams, and to launch super stealthy attacks that are designed to fool our best defenses. It's a nonstop, high-tech arms race. So, where does all this leave us? We've seen how AI is managing complexity from the tiniest chip to the global network, but we've also seen the risks. And that brings us to our final and maybe most important idea: managing the managers.
Look, the future isn't some epic battle of humans versus AI. It's a new kind of partnership. Our job is changing. We're evolving from being the hands-on doers of every technical task to becoming the strategists and the governors. Our role now is to set the goals, to draw the ethical lines, and to provide that crucial human oversight for the AI systems that are now managing our world for us.
And that leaves us with one last thought to chew on. As we get better and better at teaching our machines how to handle this insane level of complexity, the most important question we have to ask is, who's teaching us how to manage these incredibly powerful new managers?